Well, I seem to be live at the moment. I was actually just intending to give a preview about the live streaming I'm planning for Saturday the 22nd of February. That's 1900 hours UK time, 7 p.m. 1400 hours, 2 p.m. in New York, and 11 in the morning LA time. Now, you just can't do these so that they're friendly for everyone, because everyone in Australia will be asleep at that time. So I will do one for Australia. So sorry about that. It's nice to get all these comments. It's very gratifying. This was just me trying to learn how to do it, actually. I need a full-time technician. Any volunteers out there who can? I think there are probably notifications up. But given that we're here, we might as well take a question. Anyone got a question? I mean, basically, we're talking about this this COVID-19 disease caused by this novel coronavirus, and it's a bit of a strange one, really. The virus went from an animal reservoir, so these viruses are zoonotic. They live in the natural ecosystem. So you might wonder, what the heck are these viruses doing there? Because apparently there's like 10 to the 33 or something different types of viruses, like one with 33 noughts on the end. There's just like a phenomenal amount of these viruses. So what are they doing there? Well, I think the answer is they're just part of the natural ecosystem. So, for example, you need viruses to break down bacteria to release the carbon back into the normal carbon cycle. They're part of the ecosystem, the same as bacteria are. The decomposers, same as fungi are. They're decomposers. But this virus got from a bat. Now, normally each species has its own type of virus. There's just one type of virus, or a type of virus which is specific to a species. So, like dogs don't get measles and I don't get distemper or kennel cough. They're specific. But what happened here was, in this bat there was a mutation. And that mutation made the virus able to jump from one species to another, which is is unusual, but it did that. It's called spillover infection. And then it probably mutated again to allow it to spread from person to person. And this was due to interfering with bats and wild animals just trapping them and using them for food, which is unfortunate. So the virus actually probably went from bats to some other animals into humans, and then it spread from humans to humans, and that's how we've ended up with this novel coronavirus. So there's lots of coronaviruses in animals. The first coronavirus was discovered in the 1960s in animals. I think the first one was actually discovered in chickens, where it causes a respiratory disease in chickens, similar to what it causes in us. In most animals, it causes gastrointestinal disease. But that's how we got on with it. Right. Excuse me. I've had a cold for weeks. Can't seem to get rid of it. So what Walter Boy has asked about chloroquine. Now chloroquine's been used for years to treat malaria. And the answer is, at the moment, we don't know. It may be effective. So, some initial studies show that it may have effects against the novel coronavirus, against COVID-19. Let's hope it's true. Now, the Chinese are doing a trial on this, so we should know this in about 3 weeks. In fact, there's quite a lot of things we should know in about 3 weeks, really. We should know... We should know how the disease is levelling out in China, and unfortunately, I think we're going to see more cases around the world, and we'll understand the nature of the pandemic and how quick the pandemic is going to be. I think that's probably what's going to happen. Now, someone asked, can dogs get it? It would be surprising if dogs can get it, but the answer is we simply don't know that. So it's surprising that the virus went from bats to humans, but it did. So it'd be very surprising if the same virus could live in bats, humans and dogs. That would be surprising, but it's not impossible. And of course, the virus can mutate. So what happens is you get lots of strains of the virus. I wonder if I can go on to a different picture here. You get lots of strains of the virus. And let's try that. Yeah. So excuse me. So you get lots of strains of the virus. Now, in some people, that virus might mutate. And it could mutate into a virus which was less harmful, less virulent, less transmissible. But of course, that would die out. But there again, in someone else, the virus could mutate, and then it could convert into a virus which was more transmissible, more virulent, causing more severe disease. And that, if it was more spreadable, if it was more transmissible, then by definition that would be transmitted more, and it would spread throughout the population. It's kind of an evolution of the virus. So that is a possibility. I hope that doesn't happen, but it could happen. And of course, the thing with this virus is it's novel. That's what we first called it when it first came out, the novel coronavirus. And that means your immune system has not seen it before. So you don't know how to make antibodies to this new virus. You're going to have to make them from scratch. Now, you can do that. Of course, you can make antibodies from scratch, but it takes a bit of time. And in that time, when your body's making the antibodies, you can get sick. And we now know that you can spread the virus in that time as well, which is really quite a problem because of this asymptomatic spread of the virus that we're having. Let's see if I can find another question. I didn't actually intend to come on live now, but it seems to have worked. I'm just not sure how this is working, really. Right, people are asking about the distance you need to be away from the source. Now, we did this in a video earlier this morning. Now, initially people thought that it was droplet infection. And with droplet infection, it can go directly in large water droplets. But the thing is about aerosolized transmission, or transmission in the air, is that the water droplets you breathe out will evaporate and get smaller. And then they become more floaty, if you like. They'll like float in the air, and they can get blown in the air. And the viral particles can get blown in the air with other small particles, and they can be inhaled. And because they're so small, they can be inhaled right into the right into the lung tissue. So PM10s, microparticulate 10s, we know about this from studying diesel pollution, for example. Because when you breathe it in, the small smoke particles get right down into the bottom of your lungs. And in the case of diesel fumes, can probably cause inflammation and even cancers. But here the virus gets right down into the bottom of the lungs with this virus. And the thing about this virus is, all viruses can only work if they get into a body cell. So there's a body cell. The virus has to get into the body cell, but to get into the body cell, it has to fit onto a receptor. Only then can it go into the cell. And once it's in the cell, it will start reproducing in that cell. That's the way viruses work. They're absolute scallywags. They're what you call obligate intracellular parasites. They can't reproduce on their own. They're not sexual or anything like that. They only reproduce inside other cells, and they hijack the material in the other cells. But they only get in through these specific receptor sites on the surfaces of other cells. And those receptor sites are called ACE2 receptors, angiotensin converting enzyme type 2 receptors. And those receptors are deep down in your lungs. That's why this infection initially goes deep down in your lungs and causes this problem. But if they're inhaled, then they can be transmitted over distances. Now, I'm pretty sure this is what happened on that ship, the Diamond Princess. The virus got into the air. Now, it seems the crew were spreading the virus as well, but I think it got into the air and it was airborne spread, which has got obvious implications for the transmissibility. That's why I fear we are going to have an outbreak of this virus, a pandemic of it. I've suspected this since I first looked into the transmission characteristics of the virus and the way it was spreading. And from that, it seemed to me a good few weeks ago that it was more transmissible than people were thinking it probably was. So that's kind of what got me interested in this, really, and looking into it in more detail. And unfortunately, it looks like I'm being proved to be right. And some of the mathematical models show that 60% of the world's population could get this virus. Thank goodness most people get a mild illness. And also, it's great that children seem to be only mildly affected, but they are still affected, of course. So it's not ideal. The other thing I was really worried about was the adverse effects on pregnancy and what we call teratogenic effects, that it can damage the fetus, and it looks like that is not a significant factor as it was in the first the first SARS in 2002, 2003, where it caused miscarriage and difficulty in fetal growth. So there's some things we need to be grateful for, but there's some things that we're concerned about, and the transmissibility is one. And the other one that really concerns me is the number of people that get very sick, because they're going to need oxygen support because they're not getting enough oxygen into their blood. And if a few thousand people need that all at once, that's going to be difficult. We're going to struggle. I mean, in A&E we can struggle on a Monday morning, never mind on a difficult time. We really are going to have to think about this and make lots of oxygen available and try and recruit lots of helpers for this. And that's what's going to have to happen. And of course, the case fatality rate, the number of people that die, we know that's fairly low, but that depends crucially on how good the medical care is. So, if 14% of people are getting severe illness and we can treat those well medically, then the death rate will be very low. But if we can't treat them at all, then the death rate could be nearer, well, I don't want to put a figure on it, but it could certainly be a lot higher. So a lot depends on how well we're set up, how well we're prepared. See if there's any other views, any questions. They're going past a bit quick, I can't read any. Is the virus alive? Okay, we'll look at that one. Are viruses alive? Well, there's no question that we're alive. There's no question our complex cells, eukaryotic cells, are alive. Most eukaryotic cells are about 7 micrometers in size. They vary quite a bit. The biggest cell in the body is the female ovum, and one of the smallest ones is the male sperm, but they're all sort of similar kind of size. Bacteria are only about 1 micron in size, and they're definitely alive. But viruses are about a tenth the size of a bacteria. And they're alive in that they contain genetic material, DNA or RNA, deoxyribonucleic or acid or ribonucleic acid. The coronavirus is ribonucleic acid. That means it's only got one strand, which is a bit of a problem really, because it makes it easier to mutate, and I'm a bit concerned there's going to be further mutations. But they can only reproduce inside other living cells. So are viruses alive? Probably the answer is no, because they can't produce their own energy and they can't reproduce independently. But there again, they do reproduce and duplicate their genetic material, so they kind of are. Someone says I'm jumping off a bridge if I have coronavirus. Please don't do that. It's 82% probable you're going to have a very mild illness. We need you to look after the people that have a more severe version of it once you've recovered and developed antibodies. Now, people are asking about this secondary infection idea. Now, this is an interesting one, and the answer is that we don't really know, but what normally happens in the normal course of events is you get an infection. That's called the antigen, something your body recognises as being foreign. And the antigen stimulates the body's white cells, the lymphocytes, to make antibodies. So an antigen is an antibody stimulating molecule. It stimulates the production of antibodies. And these antibodies are the immune proteins. The posh name is the immunoglobulins. And they will combat the virus. They will kill the virus. One of the things they do, for example, is they'll clump 1,000 viral particles together, or 10,000 viral particles together, and then they'll all be gobbled up by a great big phagocytic cell, a cell that eats them, called a monocyte, or if it's in the tissues, a macrophage. So that's what normally happens. So that means that when you recover from, so the reason you recover from the illness is because your antibodies mop up your antigens. The antibodies, your immune proteins that the body makes, mops up the virus, and the virus stops releasing inflammatory chemicals, and then you stop being sick. That's what normally happens, and it means the antibodies are left in your blood afterwards. Now, the antibodies are going to confer immunity to that virus. And indeed, people have done studies where they take some of the plasma from people that have recovered, take the antibodies and put those antibodies into people that are infected to try and cure them. That's called passive immunity, benefiting from the immunity of someone else's antibodies. And as well as that, there's particular lymphocytes called memory lymphocytes that live on, a clonal group of them that they live on, and these are a particular group of lymphocytes that have the ability to produce the antibody. They can recognize the antigen and produce the antibody really quickly. So basically, in virtually all diseases, it is the case that you are immune to the disease after you've had it. Now, someone did mention dengue fever, but dengue is different because there's different types of dengue. So if you've had one type of dengue, then you are more sick when you get a reinfection, but that's with a different type of dengue. So that's very unusual that you get. Normally you're immune. Sometimes the virus can live in the body. For example, if you get chickenpox, which is a herpes zoster virus, that can live for decades in the near the spinal cord, in the dorsal root horn, in the cell bodies of the sensory neurons. It can live there for years and then come back out and cause shingles. That's quite unusual. That can happen. But if you weren't immune to this particular novel coronavirus, the COVID-19, after you've been exposed to it, I would be very surprised. And I would need some fairly good evidence to convince me that you weren't immune to it. And I would need some pretty good evidence that a secondary infection could be more serious. What I know now is based primarily on just my basic understanding of immunology, and that is that you will be resistant to the virus after you've had it. Now, the problem could be that if the virus mutates enough so that your immune system doesn't recognize it, then you could be reinfected. That's possible. Then you could be reinfected. This is why we get colds every year. You get a cold with a rhinovirus and you get immunity to that, and you get better from the cold because you make the antibodies. But then the cold virus goes away for a few months, and then you get what you call genetic drift. The genetics of it changes, or sometimes you get a big genetic change. That's called genetic shift in the nature of the virus, and then you get it again because the virus has changed. So your immune system recognized last year's virus but doesn't recognize this year's virus, and you can get it again. So that's a bit of a nuisance. So that could happen with the novel coronavirus because it mutates. It's got the potential to mutate quickly because it's an RNA, it's a ribonucleic acid virus, just with one single strand. With DNA, there's a mirror strand that can repair faults in it, but with RNA you can't get that. So it mutates more quickly. So I think the answer to that question is I would be very surprised if there was secondary reinfection after someone had it and became immune to it. So open to counter evidence on that as always, but don't know of any at the moment. I suspect once you've had it, you're going to be immune. Questions are going past too quick to see. All right, someone said, do you think schools are going to close? Schools, of course, children are in close contact. Viruses can spread readily in schools. There's no question about that. And I've been getting emails from people in various parts of the world, and they tell me that the schools in Vietnam are all closed until March, apparently. Just checking my mic. All the schools are closed, and that indicates the level of concern the Vietnamese authorities must have about this virus. If it does come to the UK, for example, the schools will close. I would imagine they have to, because otherwise the virus, even if the kids don't get it bad themselves, they're going to take it home to mum and dad. So the key is going to be things like, it depends what your job is, but home working as much as possible. I mean, I know a lot of businesses in the UK are working out how more employees can work from home more often. And I believe that teachers in various parts of the world, in China, I definitely heard this in China. I got an email from someone in China, and he said the teachers are doing online courses for school children. So children can learn from home via the internet, still with their same teachers. Presumably they can link up like we're doing now, I don't know. But there are many ways that can be done remotely. In fact, you really wonder why you need classrooms these days. You can put it all on videos. Not very good for lecturers getting jobs, but interesting. Okay, question there about the incubation period. Now, when this virus first came out, I did a report on a paper, and basically it said the incubation period was from 2 to 14 days, but it said that 95% of people would become symptomatic, if they were going to become symptomatic, after 12.5 days. So the answer is the incubation period is based on that preliminary data, but the incubation period is between 2 and 12.5 days for 95% of people that are going to get it. But of course that leaves 5% that might be longer than 12.5 days. So there could be some that are 15 or even 16 days. It's going to be a minority, but that is possible that we have these longer incubation periods. And again, I haven't seen it written down in any scientific journals, but there are anecdotal recounts of much longer incubation periods than that. And the other thing that's unclear is how long the asymptomatic period can be. So some people can actually carry diseases as carriers. They never get it. They can just spread it to others. They're just carriers. So that may happen with this condition, or they may carry it and then they get very mild disease and don't really notice they've got disease. That's quite possible. Or some people might get the infection, make the antibodies, be carriers for a period of time, and then not get the disease. So how long people can be asymptomatic for and spreading the virus, again, isn't clear. You wouldn't expect it to be more than a few days, but this virus has brought up a few surprises. So my guess at the moment would be a few days, but we don't really know. There's still lots of things we don't know. And it's not just me being a bit thick. I mean, you watch the World Health Organization. I watch these briefings every day from the World Health Organization, and they are asked questions, and a lot of the time they simply don't know. They don't know. We're learning a lot about this. The Chinese are doing massive research into a lot of these topics at the moment, so we're learning more all the time. I mean, in the early days of these videos, I was taking quite a lot of information from what we already knew about SARS-1 and the MERS, the Middle East Respiratory Syndrome virus, which is a very serious disease. So we could learn something from those, but it's surprising that this coronavirus, which is in the same family of viruses, can behave in such different ways. Fortunately, the novel coronavirus causing COVID-19 has got a much lower case fatality rate. And that's just pure fortune, really. I mean, the MERS has got something like a 35% fatality rate, but it's not very transmissible. But if we'd been really unfortunate, we could have a virus which is as transmissible as this one and as fatal as MERS. That was quite possible. It just depends on the way the virus mutates. So we've been really fortunate that this virus has mutated in a way where the case fatality rate is relatively low. But of course, unfortunate that it's mutated to be as transmissible as it is. But there again, we're fortunate it doesn't seem to cause disease in children. Because in previous epidemics, particularly the 1918-1919 pandemic, there was a peak of death. It's what you call a bimodal death distribution. There's a lot of deaths in young people and deaths in older people. Now, the deaths in older people you would expect. The deaths in younger people, young fit teenagers, you wouldn't expect. But this was caused by the virus causing inflammatory changes in the lungs and the lungs filling up with fluid, and they used to go blue, and then you used to get this cyanosis. This blue discoloration you get when the level of oxygen in the blood drops below about 86%, something like that. You start going a bit blue, called cyanosis. So if you look at the colour of your lips, if your lips are, might not too bad. If you look at the colour of your lips, then that's a good indicator, the colour. So if they start going a bit bluish, that would be a very severe sign. That's central cyanosis. Or the tongue, or any blue discoloration on the neck. That person needs oxygen fairly quickly. And that's what these people had in that epidemic, because the lungs filled up with fluid. But that doesn't seem to be happening with this virus, which is good. You get inflammatory changes in many people, but it affects older people more than younger people. Bad for the older people, but it's never good for children to get sick, of course. That's the last thing we want. I can slow these down. I can't read anything. Okay, we've got a question about bioweapons. This is an interesting one. Now, apparently there's a Chinese biological research institution near the market in Wuhan, and some journals have said that this virus seems to be a bit of the HIV virus and a bit of SARS-1 and a bit of MERS, and it's all a bit of a hodgepodge that couldn't have occurred in nature. But I've never read that in any peer-reviewed scientific journal. The trouble is, when you read these biochemistry journals, it's so complicated you can't understand the blinking things. You have to be a proper biochemist to understand it. But from reading it, the gist I get is that there's no real evidence for it being a man-made virus. Now, all governments have to have biolabs. We've got one in the UK in Porton Down. You've got some in the States. I don't know if the CDC do it. China does it. I know there's labs in Russia do it. Government has to do that to protect its people against biological weapons. Unfortunately, sometimes this can result in biological weapons being produced, of course. But let me tell you, if the Chinese government wanted to produce a bioweapon, they could produce one that was a lot more dangerous than the one they've got. I don't believe it's a bioweapon. The genetic analysis shows that it is essentially the same. Well, not essentially the same. I think 85% of the sequences are in common with the SARS-1 coronavirus. So it's known to be a coronavirus, and the genetic similarities with other known coronaviruses in animals and humans can be matched. There's only 7 coronaviruses actually cause infections in humans. There are 4 coronaviruses that cause common colds, just like sniffly nose, sore throat, just like a normal cold. Most colds are caused by rhinoviruses, but you can get coronaviruses that cause the common cold. You're miserable for a few days, then it gets better. Very mild. But so that's 4 of them. But the other 3 are the MERS, the Middle East Respiratory Syndrome, the SARS, the severe acute respiratory syndrome, and this one, the novel one, which confusingly has been called SARS-2, which is a bit of a stupid name, but we're stuck with it. Best to call it the COVID-19 disease virus. Then it's not ambiguous. Okay, there's been a question about, does this virus affect different races differently? Now, this is interesting because many diseases do affect different races differently. But these are because they have a genetic component. So there are some people are more prone to particular diseases. So, for example, Asians are more prone to diabetes mellitus type 2 than a lot of Caucasian people are, for genetic reasons, because they tend to store fat inside. But this is an infection. Now, what determines whether you get an infection is the infective dose that you receive, how many organisms they are, the virulence of that infective organism, how the virulence is the ability of that organism to cause disease. So how many you're exposed to, the virulence of it, how likely that organism is to cause disease, and your current immune status at the time. But with viruses, it has to get in through a particular receptor site on the surface of the cell. Viruses get in through a particular receptor on the surface of the cell. So, for example, HIV, the human immunodeficiency virus, will only, well, not only, there are others, but mostly it just goes into T helper lymphocytes, a particular type of white blood cell. So where those T helper lymphocytes are found is where the virus can get into the body. So obviously if you use dirty needles, they're in the blood. But these T helper lymphocytes are also found in the rectum, the vagina, and the glans penis. So that explains the sexual transmission of the disease. And as we've said, the COVID-19 virus gets in through the ACE receptors right down in the bottom of the lungs here. And have read some non-peer-reviewed papers that say Asian people have more of these receptors, these ACE receptors. But again, I've been looking for this, but I haven't been able to find it in a peer-reviewed journal. So I don't know that it's true. Infectious diseases generally affect all races the same. What does make a big difference, though, is your own immune status. So keeping fit, keeping healthy is good. It boosts your immunity. Eating well, plenty of flavonoids, fruit and vegetables, and enough protein boosts the immunity. Well, not so much boost the immunity, but if you're short of these things, if you're malnourished, your immunity goes down. So deficiencies certainly cause malnutrition. There's no question that deficiencies cause malnutrition. That's well known. Lack of vitamin D can be a factor in people in the north. So where I live, it's kind of grey outside most of the time. It's dark just now, but even in daylight you don't get much sunshine, so you don't make the vitamin D. So it's good to take extra vitamin D supplements sometimes in northern latitudes. I take 25 micrograms most days when I remember. And the other thing that really boosts the immune system is sleep. Sleep is very good for immunity, so keeping your immune system as good as possible is good. And then we can wash our hands to reduce the number of viruses we're exposed to and avoid crowded areas. And the virulence of the virus, there's nothing we can do about that. It's determined by the genetics of the virus, I'm afraid. So not much we can do about that one. Right, people are asking, will it spread in all seasons? Now, again, the data for this virus is not yet specific. Now, the studies on this have been done in SARS analog viruses. So even with SARS viruses, we're not sure about this, but they have viruses that respond in very similar ways. And they did found that the SARS-1 analog viruses, which is the nearest studies we have to the current COVID-19 virus, that it survived for longest on surfaces at 5 degrees centigrade. For many days at 5 degrees centigrade. I can't remember the exact figures, but at 20 degrees centigrade it was something like a day, and at 40 degrees centigrade it was something like a few hours. So yes, the heat will protect from spread of the virus on surfaces, probably. But it probably doesn't make any difference to the droplet infection, and it probably doesn't make any difference to the airborne infection. What it can make a difference is if it's cold, the blood vessels in your nose will sort of constrict a bit. and you'll get less. This is why you get a really cold nose when it's cold, because you've got all this cold air going in and it constricts the blood vessels. And if the blood vessels are constricted, you'll be getting less white blood cells going to the area to protect you from infection. So cold weather can predispose you to infection. Cold weather can cause a cold, as we all know. But the virus has been spreading in Vietnam, it's been spreading in Singapore, it's been spreading in Hong Kong and southern parts of China. So it doesn't appear that we're going to be saved by the winter. And of course, when it's winter here, it's summer in Australia anyway. So I think the answer to that question is it's not as seasonal as influenza, for example. So unfortunately, I'm not sure the seasons are going to protect us that much. Okay, question about hand sanitizers. Now, we have this machine at work where you put this like powder over your hands, and then you just give your hands a quick wash and you put it under the ultraviolet thing, and you find out you've missed bits all over the place. You've got dirty bits here in your fingers and on the back. So you need to wash your hands like you do in hospital. So I could do a video of this, but you wash your hands, you wet your hands first, you cover it with soap, you wash the roundabout that way, thumbs, palm to palm, fingers to fingers like that, and then you rinse your hands. Now the thing about washing your hands in running water and soap is what the soap does is it breaks down the sebum. So if you'd like to feel some sebum, just put your fingers there like that. You've always got some greasy sebum there. So that sebum, it's produced by the sebaceous glands, and it's normal. It protects the surface of the skin, but the viruses and bacteria stick to that sebum. That is the point. So with soap and water, what you're doing is you're dissolving the top layer of the sebum, and then you wash it away, and then you wash the viruses away with the sebum. So you're physically washing the viruses away. Now the hand sanitizers, alcohol greater than 70% will kill the virus. So the hand sanitizers are good, but it depends on the contact time with the alcohol and the virus. So it's got to sort of stay in contact for a period of time. And of course the alcohol dries quite quickly. So they're good, they're a heck of a lot better than nothing, but they're not physically washing the virus away. So hand washing is the best. But if you can't hand wash, then hand sanitization is good, yes, but it's not as good as hand washing. That's what I would say to that. So wash your hands if you can. If you can't use a hand sanitizer, by all means. Right, someone's asked what a cytokine storm is. Right, so this is probably stimulated by yesterday's talk on fever, where we said that the virus gets into the body, it stimulates the white cells. The white cells release cytokines. These cyto is cell, kine is movement. These are chemicals that communicate between cells. And these cytokines released from the white cells, stimulated by the virus, go to the hypothalamus at the base of the brain, and that turns up your body temperature, your thermostat. Excuse me. So you get a fever as a result of that. And fever is good because that optimizes the functioning of the immune system. So in adults, it's often best just to leave someone with a fever because the immune system works better. Children's a bit of a more difficult one. But the question was, what is a cytokine storm? Now the cytokines are natural chemicals released by cells, mostly white blood cells, that help us to fight infection. So they do things like raise temperature, increase respiratory rate, make us feel sick, and all things like that. But the trouble is, if you get too many cytokines, if the body goes into overdrive, then you get this massive inflammatory reaction. Now, inflammation, if you slap yourself, you get a red bit on your hand, and that's normal, that's red inflammation. But that's caused by inflammatory mediators. But if you get inflammatory mediators released into all of the body, and they go all around the body, then basically the whole body becomes inflamed. A systemic inflammatory reaction, and we call that sepsis. So the answer is a cytokine storm. If the immune cells are releasing too many cytokines, that can cause sepsis, and that can kill you. The treatment is to kill the bacteria that's causing the sepsis. But of course, if the sepsis is caused by a virus, that's a bit trickier. We're not so good at killing viruses, and let's hope the Chinese come up with something during their trials. So we have criteria for sepsis. So it'll be a fast heart rate above your normal, above 90 beats per minute. Fast respiratory rate, so that's tachycardia, fast heart rate, fast respiratory rate, tachypnea, fever, temperature above, I can't remember what it is, 39 degrees centigrade or something would certainly qualify. So a fever, altered mental status, because if you have a sepsis, you don't think straight because your brain's being a bit poisoned and your brain's too hot. An increase in the white cell count would be a criteria. And also when you're going into shock, you get an increase in the amount of lactic acid. So normally there's plenty of blood going through the tissues of the body, and that allows aerobic metabolism to continue. But in shock, in septic shock, for example, there's a reduced perfusion of the tissues of the body with blood. So that means that the tissues of the body aren't getting enough blood, and therefore they're not getting enough oxygen. And therefore they change from aerobic metabolism to anaerobic metabolism. You know, like you do when you're sprinting or working out at the gym, you become anaerobic. And that causes the production of lactic acid, as you probably know. And the body, the amounts of lactate in the body build up. So that's what a cytokine storm is. It's this condition we call sepsis. Fast breathing, temperature, heart rate, altered mental status. Or your blood sugar can go up as well. If in non-diabetics, a raised blood sugar, because part of the systemic inflammatory immune reaction is a raise in blood sugar levels. All these things are good because they help us to fight the infection. Normally, it's good to have some extra sugar in your blood so you can shiver, produce energy. But the thing is, with a cytokine storm, the immune system overreacts and becomes part of the problem rather than part of the solution. That's what's meant by a cytokine storm. Lots of cytokines all being released at the same time, causing this massive systemic inflammatory reaction. That is a cytokine storm. A question about the virus being spread and in contaminated food. Now, cooking will kill the virus. There's no question about that. So if the virus was in an animal, for example, the MERS virus in camel meat, and you cook it, it's going to kill the virus. So the cooking process will kill it. But the problem is that food can be contaminated after it's been cooked. So if I've got some cooked food and then it's cooling down a bit and I've got the virus and I cough on it, then obviously I'm going to spread my droplet infection all over that. And then if you eat it, you're going to get it because it goes from my mucous membranes to your mucous membranes. That's how the virus gets in. It gets in through mucous membranes. So it can be spread via food, but killed by cooking, because it's getting into your mouth. Just in the same way it can be spread by getting into your mouth any other way. So if there's virus on this microphone and I touch it and then I put my fingers in my mouth or rub my eyes, then the virus is getting into the mucous membrane. So yes, it can spread by food because food goes in your mouth, but cooking will kill it. So as long as the food is hygienically treated after cooking, it'll be fine. If it's not hygienically treated after cooking, or if the food's not cooked, or you cough on your salad, or some coughs on your salad who's got the virus, then you can catch it from food in that case. But the heat will kill it. People asking about the Diamond Princess, how the virus spread. I can't remember if I mentioned this, but it spread because the people who work there, these cruise ships, they've got about 1,000 people working there, and these people specialise in things like cooking and waiters and sailing ships and navigation and working in engine rooms and all these kind of things. You wouldn't expect them to be skilled in infection control, even though their skills in infection control would be as good as my skills of driving ships, nil. So it's not surprising that they didn't quite know what to do, quite how to handle this. So cross-contamination from staff, I think, was a pretty major one, but it now seems fairly clear that the virus has been transmitted in the air from room to room. Because on these ships, the inside cabins are dependent on air and circulating air conditioning systems. And even on the outside cabins, you pay a fortune for one that opens up. So most of the outside cabins are actually sealed. So the time I went on a ship, we were on an outside cabin, but it had a glass window. You couldn't open it. So again, we're fully dependent on air conditioning. So I think it just spread around in the air. And this, of course, has got major implications for the way that we do quarantine for groups of people in the future. Because if we've got all those cases on the ship, that nearly 700 cases on the ship, came from one person who was infected got off in Hong Kong a few days before. It all came from that one person, and yet it caused such a widespread infection. So one person infecting several hundred in that case. Amazing how many people are watching. Normally about 6 people tune into these things. Okay, question there about vaccine. Now, it's not my specialist subject, but what a vaccine does is a vaccine normally takes some of the virus that's causing the disease and it kills it or weakens it. So we have killed vaccine and attenuated vaccine. So you kind of mush up the virus and put that into the vaccine, then you inject that into people. Because it's mushed up, the virus is dead, so the virus can't cause the disease, it can't reproduce, but you still have the same chemical coating on the virus. So the body learns to recognize that chemical coating on the virus, the antigens, the specific chemicals on the surface of the virus called the epitopes. The body learns to recognize those and make antibodies to it. So you have something which has got the same outside chemistry as the virus. The body can make antibodies to it, these immune proteins to it. Therefore, when the virus comes in with the same chemical on the surface, the body can recognize it and eliminate the virus, hopefully before you get the disease. That's the idea of vaccination. It's a bit like, I don't know, suppose there's a trouble eaten by tigers. Then the parent might show a child, say, well, there's a tiger there, son, it's dead. But if you see an animal like that walking around, run away, because it's going to eat you. So you recognise it from looking at a dead one, and that helps you to recognise a live one when it comes along. That's how a vaccine works, but it's not as easy as it sounds. You've got to grow up the virus, you've got to attenuate the virus or make chemical analogues of the virus. Then you've got to do toxicity trials in people. Then you've got to do larger scale clinical trials in people. Then you've got to make sure that the version of the attenuated or dead virus that you've cooked up actually stimulates an immunological response. It doesn't necessarily stimulate an immunological response. And you've got to make sure that immunological response actually improves the acquired immunity of the body, this specific acquired immunity that vaccines are there to generate. You have to make sure it does that, because vaccines have got a degree of potential harm. So if it's not working, if there's no efficacy, there's no point injecting it, and all that takes ages. So if there's a vaccine for this virus by February 2021, I will be very surprised. I suspect it's going to take at least a year and probably nearer 18 months to make a vaccine, which is a real pity, because vaccines act as a firewall. So if you have one infected person and you have vaccinated people around about them, that breaks the chain of transmission. This is called herd immunity, where if there's enough people in the herd, that's us, that's the general population, we call it a herd for some reason, then that's going to stop the spread of the virus, which of course is brilliant. That's exactly what we want. But that's not going to happen in the immediate future, unfortunately. It's not going to happen. Trying to get a question out of all these things that are flicking past. Okay, there's a question there about CDC announcements, the Centre for Disease Control. Okay, now a lot of people have been criticising the. I was confusing that with the World Health Organization. So by way of background here, the World Health Organization is a global body, but the CDC, the Centre for Disease Control, is in Atlanta, which I believe is in Georgia. Some Americans will correct me if I'm wrong. And they issue guidelines, which are quite useful. So if you look on their website, they've got things like useful questions and answers. Now, given that we don't know too much about this virus, and given that there's a lack of scientific clinical trial data on this virus, the next best thing we need to do when we're trying to be evidence-based is take expert opinion. And places like the CDC in the States and places like the CDC, the Centre for Disease Control in China, they employ the best people. They've got doctors that specialise in all these things, and they are in a good position to know. So basically we've got to take their opinion. That's the best guess we've got at the moment. So yeah. Didn't actually plan doing this this video at the moment. This is an impromptu thing. We will do that one on Sunday. I'll just put that back on the screen so you can check it in a minute. That one will be on Sunday. I actually got an email today from Dr. Tetris, the head of the World Health Organization. I was really chuffed. Well, not an email. He left feedback on the video and said this is a good site. It's reliable information. So I was really quite made up about that. It was good of him to bother writing to me. Anyway, what other questions do we have? Amazing how many people are watching. Yeah, people are asking about the the publicity with this. Now, you've got to be careful here. But what seems to have happened is the World Health Organization and various governments around the world don't want misinformation about this virus spread around the world, which of course is good because we don't want people telling us to do things that might be dangerous. In healthcare, in a sense, it doesn't matter what you do as long as you don't do any harm. So this is what Hippocrates said in ancient Greece: first do no harm. And if you work in professional healthcare, you realise that everything that we do carries risks. So every drug I give, there is a risk of side effects or adverse effects or reactions or allergies, or everything has risks. If there's a chance it can work, like surgery, which works, if it's going to work, then there is a risk that things can go wrong. Now, the only thing where nothing can go wrong is homeopathy, because you're not giving any active molecules, so that can't have any side effects. But apart from that, everything has. Of course, it can't do anything either. But so everything has potential adverse effects. So people that don't work in healthcare don't realise this. So they kind of, or not as much, and they're quite happy to give advice, and often that advice can be dangerous. So various governments and the World Health Organization have tried to limit the amount of advice that people are giving. And that means things like YouTube, you can't monetize your videos, for example. So that demotivates people from doing that. Google searches, that Google searches are preferentially putting up search results from official bodies like the World Health Organization, like the CDC, like national government guidelines, which is all good. So I don't think there's a conspiracy theory here. I think it's actually a genuine attempt to keep everyone safe. But for people like me, it's pretty inconvenient because you can't quite say what you want. But yeah, YouTube still put your content on, so you can't complain about it. It's nothing. It's good. So I don't think it's a conspiracy, but there is a reluctance to share ideas from individuals, shall we say, which, okay, yeah, I can kind of understand that. There's a biblical phrase, not everyone should assume to teach, because those of us who teach will be judged more severely than most. And that's true. It terrifies me that people could do something wrong because I've taught something wrong. That's so I can kind of see why they're keeping information controlled, shall we say? Information controlled. Okay, people are asking about spread in different countries. Now, again, this is something that's concerned me from the start. If this virus gets into areas with poorly developed healthcare systems, then a lot of the people there won't have access to medical diagnosis, they won't have access to blood tests, they certainly won't have access to the swabbing that's needed to diagnose the virus with this fairly complicated polymerase chain reaction. And even if they were ill with it, then they've no access to medical facilities very often, or very basic rudimentary medical facilities. That means that the virus is free to spread in these areas. So you're going to end up with a centre of spread. You're going to get clusters in various places, probably particularly cities, probably particular poorer areas of cities with a lot of population density. And then, of course, the virus is going to spread out from there because people don't realise, viruses don't realise borders. This is why it's so important to try and upgrade health services around the world, even if it's just vested self-interest. We really need to try and improve global health services and global levels of education. And of course, this is one way to do this. This is why I do this. It's a brilliant way to communicate this sort of information. But what this means is there could be a lot of outbreaks and spread in poorer parts of the world. That is a possible way that this could become a pandemic. We don't know yet, but it's starting to look that way. Yeah. The questions are going past too quick. What else can I tell you that's important? Yeah, some people have asked this actually. Protecting yourself and your family, of course, is very important. And the main thing is not to mix in, not to go out if you can avoid it. So if there's a lot of virus in your area, then try and stay at home as much as you can and don't encourage visitors. In fact, don't allow visitors. Wash your hands thoroughly when you come back in. Try not to touch your face. Face masks have some benefit, not as much as a lot of people think that they will have some benefit. But good hygiene and not socialising are probably the main things, and trying to keep your own immune system up. And remember, it is spread in faeces, so meticulous toilet hygiene, and cleaning surfaces with ordinary kitchen disinfectants. Just get the normal bleach or whatever it is from the supermarket, follow the instructions, and disinfect surfaces, and that is going to help reduce spread and hopefully protect you and your family. There's another interesting question. Is this going to go away again? Now, the MERS, the other coronavirus, that's doesn't spread from person to person. It comes from camels. But the SARS-1 was eradicated altogether. But the thing with the SARS-1, there's no people with SARS-1 in the world at the moment. No one's got it. It's all gone. Probably still in animals, but it's all gone. So the SARS-1 is completely gone. No one's got it. But this virus may or may not do that. So some viruses become what we call endemic. Endemic means that the disease is always there. So there's two possibilities. Either this virus will be eradicated altogether, or it will become endemic and we'll have outbreaks of it from time to time into the indefinite future, unfortunately. Which one of those is going to transpire yet, we have no idea, but it could become endemic. I do hope not, but it could become endemic, which would be... It's just another problem as well as everything else, isn't it? We've got enough infections as it is, and enough problems in the world without an extra virus being endemic. Let's hope that's not the case. Right. Yeah, the identification. Yeah. That's one of the things with this COVID-19, with the asymptomatic carriers. Now, one of the reasons we could eradicate SARS and have eradicated SARS is people weren't infectious in the incubation period. They only became infectious when they were sick. In fact, they were only most infectious during the second week of the illness, when they were really quite sick. So that's good, because it means you can recognise the people that are infectious. So if you see someone who's sick, you can think, they're sick. Therefore, if they're sick, they're probably infectious. Therefore, I'll keep away from them. Or I'll wear all my PPE, my personal protective equipment, if I'm a nurse or a doctor looking after those patients. But this one's different, and that's one reason why it's spread so quickly as well. So that's part of the problem, the difference in the way it spreads between the original SARS and the current SARS-2, as it's called. Lots of questions about treatments. At the moment, we have no definitive treatments. It's just supportive therapy. I mean, the main thing about treatment is keeping your patients oxygenated, keeping enough oxygen in the blood while you're getting better. I just wonder if I've got my oxygen probes there. Next time I'll bring my oxygen probes and show you about oxygen saturations. But you need enough oxygen in your blood to supply the organs of the body, otherwise it becomes hypoxic, and that's what can kill people. So the support with oxygen is absolutely vital, that we can support people with oxygen. Okay. How long has this been going for? Yeah, some people have heard much longer incubation periods. Could be right. I haven't read it in the peer-reviewed literature, but you could actually be right. one of the things I've tried to do here is review like scientific papers, but they seem to get less views because I suppose they're quite hard work wading through a scientific paper, but it's where we get the definitive information from. So that's what we have to try and stick with. I've worked out how to slow the questions down. Right, okay. Yeah, someone's asking, will the virus become endemic, cause it to become less? Oh, yeah, okay. So someone's saying if the virus becomes endemic, will it become less infectious? Or less virulent? Yes, a lot of people, if the virus becomes endemic, then a lot of people will make antibodies to it. A lot of people will be immune to it. So that's true. So it will spread much more slowly through the population, because when the virus is spreading through the population, it'll sort of, as it were, bump into people that are immune to it, and they're not going to contract it and they're not going to spread it. So yes, the increase in immunity is going to help quite dramatically. But the problem with endemic viruses, especially RNA viruses, is they can mutate. And you can get big genetic changes. So the more viruses there are around, the greater the probability of mutation. Because any virus can mutate, and if there's so many millions of copies of the virus, then that mutation becomes more likely. And as we've said, benign mutations will die out, whereas harmful mutations can stick around for long periods of time. But of course, after about 18 months, certainly in a couple of years, we should have a effective vaccine, hopefully. Okay. Quite a few people are asking: can this virus be spread by flatulence? The answer is, of course, I haven't got a clue. Now there's fecal material in the colon, obviously. What flatulence is gases coming from the colon, generated by bacterial action in the colon. So the gases have been in close contact with fecal material. So it's not inconceivable that viruses could come out with that. I suppose that is possible. I would say it's much more likely to be in the solid of the feces in a toilet, which is then aerosolized. So my guess would be flatulence would not be a big modality of spread. That would be my guess. Will it be in tap water? That's a good question as well. The answer is not as far as I know. Not as far as I know, it won't be spread in water. The big exception there would be, though, fecal oral transmission. So if there was... The reason people get food poisoning, I remember I was in India once and I drank a bottle of water that someone gave me, and I was sick as anything because it was contaminated with sewage. So basically what that meant is someone else's feces had got into my mouth and made me sick. And albeit in small amounts, it's a revolting thought, but it's called fecal oral transmission. So contaminated feces in water could certainly cause the infection, yes, because it's getting from someone else's feces into the mouth. So in water, yes, through contaminated feces. Otherwise, probably not in tap water, because tap water is kept fairly clean. The numbers, the numbers in China. Look, the Chinese government in Wuhan and Hubei, and even the national Chinese government, are admitting that these numbers are underreported. We know that. So the real incidence is higher. There's many more people getting infected than we know about. Now, I don't know that this is deliberate. I don't think this is deliberate. I mean, in the early stages of any infection, you get a lot of people that get relatively mild disease that don't report it as a disease. So, if you think there's 100 people have got it in a population, then probably 10 times that have got it. It could be 1,000. But of course, that means that the mortality rates are much less. So if you think 100 people have got it and 2 die, that's 2% mortality. But if actually 1,000 had it, that's 0.2% mortality. That's one reason that the death rates seem much higher in Hubei for sick people, because these are like a self-selecting sample. So the numbers, yes, they are gross underestimates. We know they're gross underestimates. There's no question about that. Are they 10 times more than the actual numbers? That would be a reasonable guess. Probably a reasonable guess. Yeah, I mean, I get so many question there about travel. Do you think we should be travelling? I think one of the risks is air travel, because you're stuck in a aluminium tube with hundreds of other people. I know they circulate the air to some extent. I know they have filters, but you're still sitting about that far away from someone, and people walking up and down the corridor and all sorts of things. So people are asking me, should I be travelling? Of course, I can't answer that. You've got to decide that for yourself. The airlines have to decide that. Is there an increased risk associated with travelling? Yes, there's an increased risk associated with a lot of people if the virus is around in the environment. So the more cases that are around, the more likely it is to spread in a travel environment. Yeah. Do we need to travel less for a period of time? Yeah, I think we probably do. Sorry, I'm talking too fast, aren't I? I do apologise. It's the first time I've done this for this virus. I'll get it right next time. Are we reaching the peak? Is another question. Now, cases in China are starting to go down at the moment, but this is because the Chinese are taking such extraordinary measures to shut down whole areas. To get into a housing complex or a block of flats, you have to have a pass to show that that's where you live. You can't go and visit people. And people aren't going to work. Holidays have been extended. Kids aren't going to school. There's been massive social isolation measures, and this is slowing everything down. So it is slowing things down. But what that tends to do is, what you don't want is the numbers to go up really rapidly, then go down rapidly, because when the numbers are really high, we can't treat them all. So what you want is to slow the infection down, so the rise is much more gradual in nature. That's what we want a much more gradual rise. So the models I've read estimate that the infection is probably going to peak in Wuhan in the next couple of weeks, and that in China the peak of the epidemic in other cities are going to be behind that by a lag of 2 weeks, 3 weeks, 4 weeks, depending on the part of China that's infected. There's going to be this lag time, and likewise, if this does become a pandemic, there's going to be a lag time here as well. So I would imagine in places like Europe, the UK, the States, we're probably going to start seeing person-to-person spread established in 3 or 4 weeks' time, if it's going to happen. And then the peak of the epidemic will probably be this summer. and after that cases should hopefully start getting down. But I noticed the modelers do talk about the number of people that get the infection in the first year. So if this does become pandemic, it's going to be around for a year or more. It's not going to be a few weeks and then it goes away again. But what we're saying is Hubei, Wuhan area probably going to peak in the next 2 or 3 weeks. The rest of China 2 or 3 weeks after that, and other places in the world 2 or 3 weeks after that. Well, no, about 2-3 weeks from now, where we get person-to-person spread, and then probably peaking in 3 or 4, 5 months in other countries. I hope that prediction's wrong, but that could be. So, are we at the peak yet? The answer is no. I don't think we're at the peak yet. Someone's just told me there's been 2 sick Australians evacuated from the Diamond Princess. Okay, that doesn't surprise me really. What are super spreaders? Okay, that's a good question. Now, in an epidemic, you have a figure called the R0, and the R0 is the index of spread. So if the R0 is 2, then that means on average each infected person will affect 2 other people. If the R0 is 5, that means, so measles for example, the R0 is about 8, 9. So that means each person infected with measles tends to infect 8 or 9 others, and then they infect 8 or 9 others. So that's the R0. But the R0 is not something which is intrinsic to the virus. So, for example, if you have an infection like you had in China where the R0 was, say, 2.6, and then you close down a city and you stop travel and you stop people going to work and you stop kids going to school, then those measures are going to reduce the spread of the infection, of course. So the average person then spreads it to less than 2.6. So you get that down to about 1.6 or something. So the R0 is not intrinsic to the transmissibility of the virus. It's a combination of the transmissibility of the virus and the particular social environment it finds itself in at the time. And given it's an average figure, some people are going to spread it less than that, and other people are going to spread it more than that. And this is what a super spreader is. It's a person that spreads it to many people. It's an above average spreader. So in the UK, we had this guy who picked up the disease in Singapore, stayed with a chalet with his mates in France, gave it to 4 people there, flew back to England, went to a yoga class and went to a pub in Brighton, I think it was. Bournemouth, somewhere down south, Brighton or Bournemouth, I can't remember. And then gave it to more people. So he ended up infecting about 10 people. So his individual R0 was way above the average R0. So he was a super spreader. He spread it to many people. But super spreaders may have a biological basis as well, because super spreaders might be able to retain the virus in their respiratory tracts but not get the illness. Or super spreaders might not get the illness but retain large numbers of the virus in their respiratory tract for some reason. So there's biological reasons for super spreaders, and there are environmental reasons for super spreaders as well. So that's what a super spreader is. It's just that. It's someone who spreads to a lot of cases. In fact, that was one of the concerns early in this condition. There were reports that after people were well, you could still culture the virus from their respiratory tracts and from their saliva. And it looked like the virus might be retained in the respiratory tract and the saliva, therefore rendering a person infectious for some time after they were better. But it looks like this isn't typical, that the virus is eradicated a few days after the infection. It's starting to look that way now. And the reason I think that is the Chinese are posting very large numbers of people that are recovered from the virus. People that are essentially cured, they're essentially better. But the Chinese criteria for this are quite strict. They don't say, oh, you look a bit better, clear off, you go on the well list now. What they actually do is they have to say these people have had no fever for 10 days, afebrile for 10 days, that their chest x-ray or lung CT is improving, that the infiltrates that got into their lungs are getting better and going away, and also that they have 2 negative swabs. So that's actually quite exacting criteria for that. So, what that means is that people are in fact eradicating the virus, meaning that they will no longer be infectious. So the virus can be eliminated, which of course is very encouraging. I think some of you are getting bored. Like, can a pneumonia vaccine help? Okay, so what happens with pneumonia is in pneumonia, if you think about the small airways in the lungs, these air sacs here, so these are the respiratory bronchioles. These are the alveolar air sacs. And that would be so that's a terminal bronchiole. They're respiratory bronchioles. The bronchioles are the very small air passages. This would be the alveoli. Now what happens is in pneumonia, infection causes inflammation and you get fluid building up in here like that. So pneumonia is infection in the lung tissue at the level of the alveoli. That's what pneumonia is. And of course, when they're full of fluid, the oxygen can't get out into the blood, and the carbon dioxide can't get from the blood back into the lungs to be breathed out. Now, the problem is with pneumonia is it's caused by the problem with pneumonia is it's the same pathology that the alveoli fill up with this fluid, but that inflammation can be caused by a wide variety of different organisms. So, for example, often the most severe pneumonia is bacterial in nature. In fact, we have an organism, Streptococcus pneumoniae, which we just call pneumococcus for short because it causes pneumonia so often. That's like classic pneumonia, where you often get the rust-coloured sputum. But then pneumonia can be caused by Staphylococcus. It can be caused by lots of atypical bacteria. And of course, it can be caused by viruses. So this inflammation could be caused by MERS or SARS or the new novel coronavirus, the COVID-19. So there are vaccines for different organisms that cause pneumonia. So Haemophilus, for example, you can the Hib vaccine, because Haemophilus bacteria can cause pneumonia, but that won't protect you against pneumonia caused by a different organism. So the vaccine will protect you against a specific organism, whereas pneumonia is really a descriptive term meaning infection and inflammation at the level of the alveoli. So a vaccine for Haemophilus or a vaccine for pneumococcus will have no effect whatsoever on the chances of developing a viral pneumonia. So it's a good question, but the answer is no. Vaccines for pneumonia, other types of pneumonia, will not protect you at all, unfortunately. But good idea. Keep thinking of these good ideas. Okay, maybe one more, then it's bedtime. I think we've done an hour and a bit. Okay. Question about ibuprofen. Does ibuprofen work? Now, ibuprofen is in a group of drugs called non-steroidal anti-inflammatory drugs. So aspirin, ibuprofen, diclofenac, indomethacin, probably different names in the States, but they're all non-steroidal anti-inflammatory drugs. So they're anti-inflammatory, but they're not steroid. And these have different effects. So if you take them for a day or two, they become anti-inflammatory. If you take them for a short period of time, they act as painkillers. They are analgesics. But like paracetamol, so in the States, paracetamol is acetaminophen. What ibuprofen will do, so paracetamol, ibuprofen, acetaminophen, what they all do is if the body temperature is high, so your body temperature is 39, if you're febrile, if you've got a fever, they'll bring it back down to normal. They're described as antipyretics. They reduce body temperature. And they do this by working at the level of the hypothalamus that controls the body temperature. So they interfere with something called prostaglandins in the hypothalamus, and it's the prostaglandins in the hypothalamus that are stimulating the fever and the pyrexia. Now, to say does ibuprofen work, does paracetamol work, the answer is yes, obviously it works because it lowers the temperatures. It lowers the temperatures effectively. So what happens is if your temperature's say 39 and you take some ibuprofen or paracetamol, about 20 minutes after you take it, you start feeling really hot. And then you start feeling a lot better because what it's doing is it's affecting your hypothalamus. It's bringing your temperature down. And it brings your temperature down by making you vasodilate. So the warm blood goes to the surface of your body, gives off the heat. You lose the fever and you feel better. So it works, it makes you feel better. It reduces the fever. It's antipyretic. But the reason you have the fever is because the white blood cells have gone to all the bother of making the pyrogens, the cytokine pyrogens, to stimulate the hypothalamus, to give you the fever. The reason you have the fever is there's all these clever mechanisms based on prostaglandins in the hypothalamus that are designed to raise the set point so that your body comes up to that set point. That's why you feel cold when you're getting a fever, because your body's trying to warm you up. And when you're hot, when you're pyrexial, that reduces the virulence of the viruses and the bacteria. They don't like being hot like that. And it also promotes the function of the immune system. So certainly in an adult, fever is a highly protective mechanism. So if you take paracetamol or ibuprofen, that's going to bring your fever down. That's going to make it easier for the viruses to multiply. Bringing the fever down is going to reduce the efficiency of your immune system. If you reduce the efficiency of the immune system, that means the virus can multiply more and spread more and affect more cells. That means the illness can last for longer. The illness ultimately can be more severe, and ultimately there can be more sequelae as a result of the illness. So does ibuprofen, paracetamol work? Absolutely. You feel better in no time. If you're feeling awful, I come and give you 2 paracetamol, you feel better half an hour later, you think, oh, John's really clever, he's given me some paracetamol. And I tell you what, I don't know, I feel better. In just half an hour, I feel better. That's true, you will. But I've reduced the efficiency of your immune system. So ibuprofen and paracetamol have zero antiviral properties. They do not kill viruses. They just treat the symptom of fever. But the reason you had the fever in the first place was to optimize the efficiency of the immune system. So usually not a good idea. You can never, there's no such thing as a universal rule, but I try and avoid antipyretics, certainly in adults where I can, if the fever is caused by infection, because I know that is helping to get rid of the infection. So yes, it works. It brings down your temperature. No, it doesn't kill the virus is the answer. Ibuprofen, paracetamol, aspirin, all these kind of things. How long can China keep the cities under quarantine? Yeah, that's a good question. Quite a long time is probably the answer. But that brings us on to the economic adverse effects of the virus, which are going to be really quite significant. There are going to be a lot of economic consequences from this. I mean, they can keep them locked down as long as they keep delivering food to the people, I would imagine, but it's difficult. Yeah, is SARS-CoV, yeah, is the new virus antibody dependent? We've kind of answered that question, really. The answer is no, I don't think it is. Because normally the antibodies will fight the infection. But sometimes can you get a virus and the antibodies that combine together? Now, this happens with viruses and bacteria, where the virus or the bacteria and the antibody can combine together, and this forms what we call immune complexes. And there are some autoimmune diseases that can be caused by immune complexes. What's that one that affects the kidneys called? I can't remember. Glomerulonephritis can be caused by immune complexes. Very serious condition, glomerulonephritis, or it can be caused by that. So it is a possible antibody-dependent pathology is possible. But personally, I haven't read any evidence that this occurs in the current COVID-19. If you can find evidence for that in medical journals, then yes, do believe that. But at the moment, I haven't come across it. Okay. I didn't plan on doing this tonight. This is just because this is because I can't work the YouTube system properly. We'll have to get it worked out for next time. Okay. Does this have the potential to wipe out humanity completely? No. I don't believe it does, because even the most virulent virus, you get some people that are naturally immune to it. And we know that with this virus, as it is at the moment, 80% of people have a mild illness and make a full recovery. So it's got the potential to harm a lot of people, to kill a lot of people, especially if they don't have access to medical care. But no, it's certainly not an existential threat to the whole human race. These infectious diseases have come and gone over the centuries. In my country, there's one called the Black Death, bubonic plague, and it killed about 40 or 50% of the population. It was unbelievable. 1348 it arrived. And there's been other outbreaks since. Smallpox was terribly devastating for the Native Americans in North and South America. So there's always been outbreaks of new disease. But there's always a minority of people that are immune to them and don't get it. But with this, as we say, most people get a mild version. And after that, everything that we know at the moment means that after they've had a mild disease, they're going to make a full recovery, and at least 80% of cases get a mild disease. And after that, as far as we know, they're going to be immune. So no, it's not going to kill all of humanity. Okay. one more question and that's it. We've been going on for a while now. We will have this planned one on Saturday. Right. Okay. Someone's asking me how long. This is going to be the last question. Okay, we'll make this the last one. How long can this survive on packages from China in cardboard boxes? The answer is I don't know. The studies on the MERS, not the MERS, the SARS virus analogues were done on stainless steel. But on surfaces generally, there's no reason why the virus shouldn't survive for quite a good few days. So what I would do, parcels from China, if you're worried about this, just take your parcel from China and leave it somewhere warm for a couple of weeks and then open it, and by that time any viruses that are there will probably have died. I'd actually checked this on the CDC website, the American CDC website, and they said there's probably no risk in parcels from China. So there's probably no risk. They weren't saying there's absolutely no risk. But the longer you leave it, the more opportunity there would be for any viruses to die, is what I would say. Okay. I have done a couple of these before on my channel, but I still don't know quite what I'm doing really. But anyway, I think we'll leave it there. I know there's still 4,000 people watching, but we can't go on forever. We've done an hour and 36 minutes. So 9 o'clock. Where's my crib sheet? 9 o'clock. Yeah. Saturday, the 22nd of February. Next Saturday, 7 o'clock in the evening UK time, 2 o'clock in the afternoon New York, 11 o'clock in the morning Western US time. And I will do another one that's a friendly time for our brothers and sisters in Australia. Okay, well, I do appreciate you joining me. It's really nice to know that people are interested, that people are listening. Yeah, it's good to know. Right, okay. Well, God bless you all, and we'll meet again on Saturday. Having said that, I'm going to have to rehearse this again, so I might end up going on air inadvertently, but for now, good night or good morning if it's where you are, and God bless. Okay, well, we'll meet again soon. Thanks for coming in. I appreciate it. It's great to know you're there.